Hello, my name is Roger Martin. I am a senior software developer working for Task on the UBA project. I wanted to throw together this Wallaby Power Tricks video because Wallaby has dramatically increased my own efficiency in writing and maintaining unit tests. I know a lot of us are using Wallaby already, but we may not know about the live comments feature that it offers. And when I discovered that, I was pretty blown away. Like, I already thought Wallaby was pretty cool, but using the live comments feature provides a near debugger-like experience in working with your unit tests. And that's important because as far as I know, you can't use your actual debugger to step through code in your unit tests. At least I haven't found a way to do that. So in this video, I'm going to quickly go through installing and running Wallaby. I'm just going to burn through that real fast. I'm going to spend most of the time working, explaining this live comments feature and how that provides a near debugger-like experience. And I will touch on the performance analysis and code coverage functionality in Wallaby as well. So let's get this party started. All right, let's get Wallaby installed and activated. Now Wallaby is installed as an extension into your code editor. I'm using VS Code, so I'm going to show you how to install Wallaby into VS Code. So go to the Extensions tab, type Wallaby. There it is. In my case, I already have it installed, but if you don't, you'll see an install button. Go ahead and click that and install it. Once installed, you'll need to activate it with your license. Task has purchased several licenses for us to use. To get a license, go to Confluence, and then just do a search for Wallaby. And here's a page, Wallaby.js license keys. Now, you can see the first several keys are assigned to developers. If you need a new key, you scroll down until you see the available keys. Here's the first available key. You can grab that key, put it into your clipboard, and then be sure to update this page and replace the word available with your name so that Task can keep track of which license keys are assigned to which developers. So once that license key is on your clipboard, go back to VS Code, open up the command palette, which is Shift Command P in Mac, Shift Control P on Windows, and type Wallaby, and you want the manage license key, which in my case is the first one here. So I'm going to select that. Then you paste your key into there, hit enter, and boom, you're activated. All right, let's run Wallaby against our repositories. Now our UBA and admin UI repositories are already configured to use Wallaby, so running it is really easy. Open up the command palette, Command Shift P, and type Wallaby, and you want to do start. As soon as you hit start, down in the lower right corner, you can see this cool Night Rider thing. That's telling you that Wallaby is starting to run the unit tests, and you won't see anything until all of the unit tests have run. So it takes a few minutes. So I'm going to pause the video here and then come back when it's done. Okay, the Wallaby tests have spun up. The first thing we'll notice in the lower right corner is that Wallaby is reporting 1,318 unit tests are passing and 0 are failing. Let's open up a particular unit test file. This is one that I've recently worked on, card package validator .spec, and that exercises the validation function in cardpackage.validator.ts. And it has to do with validating that the state of a card package object is suitable for persisting to the database. When we look at the unit test, we see all these green squares, which are indicating successful unit tests and lines of code that are part of the unit test. So we have all greens, that's good. In the code file itself, where this is the class that we're exercising with the unit test, we also have green squares, and that's indicating that unit tests are appropriately hitting and passing those lines of code. If I scroll down, I want to see lots of green squares showing that I'm exercising all my code. Now here is a function that is not getting hit by unit tests. Get all card packages. And You can tell by the light green square. In this case, it's okay. That function is hitting the database, and we don't need a unit test for that. Same thing with this other function. That's hitting the database. We don't need a unit test for that. Now, what would it look like if one of these unit tests weren't running? So I'm just going to comment out this unit test here. And Wallaby updates automatically and stops running that particular test. And if we go back and look at our validator class and scroll down, and let's look to see if anything is not getting hit. Aha! Here's a line, 103. This is no longer getting hit by any unit test. So it's really helpful to scan the Wallaby squares in your class files while Wallaby is running and see if particular sections of code are not getting hit by your unit tests, because this is a red flag, or a light gray flag in this case, that is telling us, hey, we don't have a unit test for this line of code. So if I uncomment that line again, Wallaby will immediately run the test, it's passing, and when we bounce back, we can see that, yes, this line is getting hit. So, so far this is pretty basic Wallaby stuff, and I want to kind of quickly pass through the basics of Wallaby, because you can figure that out pretty quickly on your own or just by asking another dev. What I want to get to is the functionality in Wallaby that I thought rocked and that probably not too many people know about. And the reason why it rocks to me is because of a frustration I've had with unit tests. To my knowledge, it is not possible to use the debugger in VS Code to step through unit tests and the code that those unit tests are exercising. And that really slows down the development of unit tests and maintenance, and makes it harder to troubleshoot when a previously working unit test is no longer working. So I want to show you this cool new stuff that Wallaby allows you to do. So let's start by intentionally causing one of our unit tests to fail. And I think we should focus on this one here. So this is a test that's kind of a happy path test. It should succeed when we're adding a new card package and the data is valid. The first line in this unit test gets a new card package from our test fixture, then it calls the custom validate function. This is the function that we're exercising here in the card package validator. And then we check to see that there are no errors in the return value. So the easiest way to fail this would be for me to copy line 28, paste it in right here. And now we see that we expected 0 properties on the errors object, and we got 1 property on the errors object, and that's causing the test to fail. And let's try and figure out why this test is failing. Notice if I hover over my variables, VS Code isn't really giving me much in the way of useful information. But, so here's this magic Wallaby syntax. And it looks like that. When you add that to the right of any variable or expression in Wallaby, Wallaby will produce an overlay or a pop-up with the contents of that object or property. And now here we can see we have a duplicate card package nickname is the property, and then there's a description of what happened. We can also use that syntax to give us information about other variables. So if I paste that to the end of this first line here, and then hover over card package, I see all of the properties of card package. Really sweet. So this works not only in the unit test, this works in our class files as well. So right now, if I hover over has clients, I'm not seeing what the value of has clients is. But as soon as I paste that special syntax, which Wallaby calls a live comment, now I see the value. Now, why are there a whole bunch? Has clients, it's not an array variable. It's a constant. It's a single Boolean variable. The reason why there's several listed is because Wallaby is showing the value for each unit test that's exercising it. And that can sometimes clutter things up and make it a little more difficult for you to work through a unit test, especially if there's just one you want to concentrate on. So what I'll do often is just comment out all the unit tests in a file except for the one I'm interested in. So I'm going to do that here. There. Now there's just one unit test in this file that's running. And when I go back and look, I can see that has clients just has a single true value. So I can paste that syntax at the end of each one of these lines. And let's see what that gives us. Give Wallaby a few seconds to reevaluate everything. And now what we see is the output of all of these variables. So we have our has clients is true. Our all card packages variable, we see that it's an array, and there are 2 items in there. Existing card package in DB, and we see that's undefined. State validator has that property and value. Our errors object is an empty object here, it's an empty object here, it's an empty object here. But here it gets assigned a property. So Wallaby is telling us that, hey, this function is doing something that's relevant to us right now. It's populating that property. And if I drop down into that function, this red square on line 99 is giving me another clue that this is the line that's running that is causing the unit test to fail. And if we were truly interested in troubleshooting this, or maybe this was a problem, now we will have quickly drilled down right into the 1 or 2 lines of code that are maybe relevant to our unit test failure. I'm going to go back up to the custom validate function. I'm going to undo those live comments just to kind of clean up the UI a little bit and clutter things. And I want to tell you that you don't have to just paste that at the end. You can paste that to the right of any expression. So here, if I put that there, now Wallaby is popping up the value of the length property. It's 1 in this case. If I paste it here, we're seeing the value of vendor package ID. Which is not 1. There, package, I see it on the left side there, package ID 01. And if I put it on card package and wait a few seconds, we should see the object itself. There's the card package object. Now that live comment supports expressions as well. So we could, let's say what we were interested in is the card package ID property and nothing else. Now we can see the card package ID property in the pop-up, but let's say that was, we only care about the card package ID. So what I could do is, I think that's the right syntax. Okay, I got the syntax. It's this $.ID, the question mark preceding it. So now that I've done that, now you can see just the ID for the card package. I could also do, I can reference variables directly like this, card package ID. Yes. So we can also do, so here, let's say we wanted to find out why the existing card package in DB variable is returning undefined. Now, the line is simple. It's looping through the all card packages array and trying to find if one of the items ID property matches the incoming card package ID into this function. So what I would do is use this syntax, card package.id. Now by doing that, by referencing card package variable here, that's telling Wallaby to ignore the fact that it's even right next to all card packages. I'm just kind of overriding that behavior. And you can see in the pop-up that we're getting just the ID. And then in the closure, we can do it again. And now we can see that the first item in the pop-up is coming from our first live comment, and the second and third items are coming from this second live comment. And the reason why there are two is because there are two items in the array, so it's running once for each item in the array. Now that's pretty clear what's going on here, why we're getting an undefined variables, because that first item just doesn't match either of the other two IDs. But notice that we can also add clarification to what we're looking at, because Wallaby supports a wide range of expressions. So I could prepend some text, card package ID. I could do that, and now the pop-up after a few seconds should show that prepended text. There it shows up. And I could do the same thing here. I'm going to, let's see, I'm going to do this. Let's see, I'm going to call it the database ID. Oops. Card package in db.id. And I have a red squiggly because the line is too long right now. But oh, and we also have, oh, there we go. Okay, so now you can see that that prepended text I wrote is showing up in the pop-up. So you can use that to help make things even more clear. So far, all we've seen is ways to view variables in a variety of ways. We can modify variables as well. So before Wallaby, if you wanted to do an experiment by, maybe you had this idea that I'm going to change the card package nickname and just see what that does to the unit test, you might have written a line of code like card package nickname equals unique, and then ran your unit test to see if it passed or failed. And we can see in this case that by changing the nickname to a unique value, that did cause the unit test to pass, and that's important information. But it is risky adding code like this, because if you accidentally commit the code with this in there, that this is not a line intended to stay in the code. You were just doing an experiment to try to get things working. So what you can do with Wallaby is include that kind of a command inside the live comment, like this. And that does the same thing that we just saw. Now, I could have put this line all by itself on the line above it, and that would have worked, but I put it here because I wanted to also show you another trick about, so let's say you wanted to see this object variable, the transition validator, and you can't at first glance because you have this live expression, live comment running here. You can add a $sign at the very end, and that will change the scope of what Wallaby is displaying to the expression to the left of the live comment. Previously, it was outputting the nickname, but by adding the $sign there, it changes it to the transition validator. So now when I hover over, you can, Wallaby is popping up the transition validator, and it's one property that's currently set. So these are really powerful tricks for getting a near debugger-like experience in your unit testing environment. Okay, the last thing to show you is the performance analysis and code coverage tools that Wallaby offers. We're going to go pretty quick because there's frankly not a lot there. For starters, the unit tests will have this overlay of the number of milliseconds that each particular unit test takes to run. So here we have 1 millisecond, and then there's 2 milliseconds, and so on. We can add special syntax to a line. It looks like the live comment that we talked about earlier, except there's a period in there. And by adding that to each line, Wallaby will output how long that particular line takes to run. So we can do that there in the unit test files. You can also do that in the code itself. So if I add that to each one of these lines, we'll see how long each of those lines takes to run. And because this function is invoked by multiple unit tests, we're actually seeing some statistical analysis of the results. The total time it takes, the average time it takes, and the min and max times it takes. If this function was only being invoked by one particular unit test, you would just see the time it takes to run. You wouldn't see the statistical result. So I'm going to get rid of those. And also, you can check performance of inside loops. So if I were to put that special syntax right here, which is inside this closure, I will get an output of the performance time it takes for each iteration of that loop. Down below, to the left of our failing and passing unit tests, Wallaby outputs a percentage, 80% in this case, and this is the percent of code coverage this particular file has. It's not for the project, it's for this particular file. So each file you go to, you'll see that number change. If you want to see the code coverage for the entire project, the only place I know of to see that, and there may be others, is the built-in web server. So Wallaby does offer a built-in web server on localhost port 51245. So this will work when you have Wallaby running. You don't have to install anything special. And the first thing you see is a list of all the unit tests, and one of the columns shows how long it takes those unit tests to run in that file. So one thing you can do is kind of scan through this list and look for any red flags, any particularly long-running unit tests. And here we have one. The tests here take 1.5 seconds to run. If we drill into it, we can see that, oh, it's one particular test that's taking the bulk of the time. If I click on the I, we can see this is the test that's doing it. And when we look at it, we see there's a set timeout with a 1500 millisecond timer. So that explains why the unit test is taking a pretty long time to run. And it looks like this timeout is intentional, and so maybe there isn't an opportunity to improve the performance of this unit test. But it's conceivable that you can use this technique to discover unit tests that maybe are inadvertently processing files in a slow manner, or just doing something else that's slow that gives you an opportunity to improve the performance. The code coverage, as I alluded to earlier, of the entire project is shown here. It's 15%, and if I click on it and wait a few seconds, we'll get a detailed report of that code coverage. Here we have in the right pane a list of all of our files, and then this column, the coverage column, shows the amount of coverage. And so we have a bunch of files with 0% code coverage. If we scroll down, eventually we'll get to some files that have some code coverage. Here, and all the way at the bottom, we do have a number of code files that have 100% code coverage. So yay for us. Overall, I haven't found the web interface to be terribly helpful. That may change or improve in coming versions. So that's it really for the performance and code analysis. If there's more to it, I'm happy to hear it, but that's about all I've been able to figure out so far. So cheers.